Hi there, this is Architect David. Welcome to Arkida, where you can learn anything and everything about construction. For this series, although it says conventional and non-conventional, we will be discussing about the non-conventional energy sources. One of the non-conventional energy sources is geothermal. Geothermal taps the steam coming out from under the soil. It goes to a turbine. The turbine turns the generator, thus generating electricity. You will notice that geothermal plants are beside inactive volcanoes. One variation of a geothermal plant is called the dry steam power plant. This taps the actual steam from underground, which in turn runs the turbine and it runs the generator, giving out electricity. Another variation of a geothermal plant, which is the most common, is called the flash steam power plant, meaning to say this gets the water from underground, and as it goes up, it becomes steam. Then that is used to turn your turbine, which in turn turns the generator. The last variation of a geothermal is called the binary cycle power plant. This taps the hot water, and in turn it will still boil that hot water to provide the steam for the turbine. Now the next variation of a non-conventional energy source is called the biomass system. This biomass is using the energy generated or produced by living or once living organisms, meaning to say it is stuck in a certain silo wherein the gas that is produced there will be used to run the boiler system for you to be able to come up with steam. Now looking at the picture below, you will see that there is a hopper. That is where you will collect all your biomass into that area. From there, it will now be transported into the gasifier wherein it will tap the gases that are being emitted by your biomass. Then it goes to a gas reformulator, gas cooler, flare system, then the actual gas engine where it will start to uh, be connected to a generator. Now another form of non-conventional energy source is hydrogen. You will take or you will tap the hydrogen liquid form wherein it will go through an electrolyzer to separate the hydrogen and the oxygen. If you know where hydrogen is going to be taken, actually that is just plain water or H2O. Now looking at the picture below, you could see a typical hydrogen power plant. If you look at the upper right portion of the picture, you will see the words hydrogen production. That is where hydrogen is now being processed, meaning to say you will place water there, then due to electrolysis, it will separate the oxygen from the hydrogen. Then the hydrogen gas is now placed at the hydrogen storage. Then it will go to a power plant. If you look at the picture on the left side portion, from that power plant, it will generate electricity to be able to be given out to the power grid. Now, one favorable element of hydrogen is called deuterium or heavy water. Heavy water, also called as deuterium oxide, is composed of two deuterium atoms and an oxygen atom. So in ordinary water, each hydrogen atom has just a single proton in its nucleus. In heavy water or deuterium, each hydrogen atom is indeed heavier with a neutron as well as a proton in its nucleus. Now in the Philippines, there is a big or vast reservoir of deuterium. Now, one point to add in non-conventional energy sources is radiant energy. It is still theoretical in nature. There are still no commercial institutions or structures that is being developed to provide energy to a big area. But if you would check the internet, you would see that there are several small scale experimentations which provides proof that there is electricity in radiant energy. So to give you an idea what radiant energy is all about, it is the physical energy resulting from electromagnetic radiation, usually observed as it radiates from a source into the surrounding environment. To give you an idea how radiant energy works, the incoming solar radiation coming from the sun, which is not actually only the heat and the light, but actually the electromagnetic energy coming from the sun is 100% being absorbed by the earth. 47% is absorbed by land and the ocean. 23% is absorbed by the air, ozone, clouds, and dust. So you can see the amount of solar radiation that the earth is absorbing. Is it being collected? No, not yet. In commercial structures or commercial sizes, it is not. So in terms of electricity, how much solar radiation are we absorbing? In the picture above, it shows we are now absorbing 174 petawatts of incoming solar radiation. The picture down below, 1 petawatt is amounting to the number of watts down below. So radiant energy was started by Nicola Tesla. If you see the picture on the left, that was his patented device, wherein the pictures on the right shows a small experimental variation which was able to get energy out of just a single aluminum plate. Now, the next scientist who developed Tesla's invention was Thomas Henry Murray, wherein the picture shows it just needs a wire at 17 meters long, 2.5 meters height, to be able to get 50 kilowatts as an output. Now, to end this video series, let me quote Thomas Henry Murray, wherein he said, "Enough energy is coming to Earth to light over 1,693,600 100-watt lamps for every human being on the Earth today." Hope you learned something new. Watch out for my next video. Click the subscribe button to discover all the other videos in this site. Click the notification bell to be notified about new videos that we post. If you have additional comments, please post them down below or at our Arkida Facebook page, and I will answer all your queries. Thank you.